Welcome to the Vodcast about hydrates and the hydrate lab. Hydrates are ionic compounds that have absorbed water. I think the real word is adsorbed, but the water is attached to the ionic compound, and yet it's like submicroscopic, so it doesn't look wet. And as you learned on a previous lab that we did, where we worked with the substance at the bottom of this slide, copper sulfate pentahydrate, you can show the number of waters that are attached by putting a dot after the chemical formula and indicating the number of waters that are attached to your ionic substance. That dot means attached, not multiply. We use Greek prefixes, not Latin, to indicate the number of waters attached. And your goal today will be to determine the number of waters that are attached to a hydrate that you and your lab partner will be assigned. So let's review what the Greek prefixes mean. Mono means one, di is two, tri 3, tetra 4. We're not using quad because that's Latin. Tetra is Greek, 4. Penta 5. I remember hexa because there's an X in the word 6 as well as in hexa. Hepta means 7, octa 8, nona 9, and deca 10. Now, the term anhydrous refers to a hydrate that's been dehydrated. It's without water. And the way we'll be doing that is through extreme heat. So at this point in time, you will need to be reaching for, if you have not already done so, pages 10 through, I believe it's page 13. And it says the mole concept formula of a hydrate. And you will be assigned one of these 5 hydrates, you and your partner. Notice that if you get hydrate number 4 with manganese, we have a special disposal method for that. The others will go into the trash can since they're fairly benign, but the manganese is a heavy metal, so it needs its own waste container to go to hazardous waste. Let's take a look at the first page of the lab. You're now on page 10. There will be a post-lab quiz that will cover anything we've done, including any introductory material that you can see here. But let's focus in on the objective. You will determine the percentage of water that's in your hydrate. You'll be able to determine what that number of moles of water is and be able to write down the correct formula. What's the number that comes after that dot? For the moment, we will not do the empirical formula of the hydrate and will complete that at a later date. The procedure is shown fairly clearly on the back of that page, on page 11. As you can see, you'll be setting up clay triangles with metal crucibles for the heating process. Now I would like to point out a couple of safety features and a few changes. So these are the lab helpers. Please write them down so that you and your partner do your lab correctly and safely. So first of all, you need goggles and apron, and goggles on at all time the moment anyone at the table, not your lab partner, but the people on the other side. If they fire up a Bunsen burner, those goggles are on. If you need to move to another table to work without goggles, please do so. In addition to that, clear all combustible material away from the Bunsen burner area. No papers, no book bags. Put your book bags on the floor under your desk. Make sure that you have closed your locker drawer. Open drawers are a tripping hazard. Okay, and so now if you take a look at what you're doing, it will describe to you various steps that are quite explicit. But on step number 4, you will heat and then weigh an empty crucible. It has to be cool on step 4 and also in step 7. Anytime you weigh a crucible that's been heated, you must let it cool off first. If it's too hot to touch, it's too hot to weigh. Weighing something that's hot can give you a false reading, lighter than the correct actual mass. Please now make a specific change on your lab. Cross off 1/3 full on step 5 and change that to 1/4 full. And of course, as you go to get your hydrate, don't touch it with your fingers, use your scapula. Please note on step 6 that your flame has to be blue. It has to be very blue because you can't use a yellow flame. It won't be hot enough to drive off the hydrate on the water on your hydrate. Also on step 8, if you get confused by that, just reread it and you will see that step 8 is just making sure that you've actually driven off all of the water. So you heat it, you weigh it, you heat it, you weigh it. And if the weight doesn't change very much, then you know that you have now heated enough to drive off all of the water to proceed. The reagent disposal to repeat. You will scrape all of your hydrates, now anhydrous, into the trash can except not number 4. But for all 5 types, you now go to a sink and use the scratchy side of your sponge to scrub the inside of that thing clean after you've scraped out the solid with your scrupula into the trash. Not only does it have to be clean, it has to be dry, and it needs to personally be returned to the teacher in a clean and dry state. You will not just return it to the supply tub. It needs to be inspected by the instructor. Now, if you go to the next page of the lab, you'll see that we have a data table. Now, a couple of these terms I'd like to repeat. If you see the term hydrate, that's referring to the original ionic substance that was wet. It had the water on it. If you see the term anhydrous salt, that means after you've heated it and dried it out. So it means without water. And salt is just a generic term that we use to describe ionic substances. Down at the bottom, you will see the term, you'll need the molar mass of your anhydrous salt. Well, just like we use the periodic table on the molar mass worksheet, you're going to go to the periodic table and calculate the mass of 1 mole of your ionic compound without water. Here's that list again. And you can simply write this down at the top of the next page, and you will go to the periodic table and find the molar mass of your dry anhydrous without water compound. Notice at the top of the following page, where you will be doing some follow-up questions, you need to write down our hydrate number was, and write that, as well as the formula. Okay, so the calculations are actually pretty simple. There are also examples in the textbook, but simple subtraction will allow you to calculate number 1. You know the mass before you heated it, you know the mass after you heated it. Whatever the difference is the amount of grams of water that was driven off from your hydrate. On calculation number 2, as you learned on the lecture on grams to moles and moles to grams, if you have grams of water, you will also need to find the molar mass of water, because grams divided by molar mass of water, or grams times 1 over the molar mass of water, it's the same thing, will give you the moles. So you simply take your grams from line number 1, divide them by the molar mass of water. You will have to calculate that, and you'll know the moles of water that was lost. Okay, on step 3, you're going to have to convert the grams of your anhydrous salt into moles. You're doing the same exact thing. You will have a mass on your data table of the anhydrous salt. You also calculated on the data table, on the very last line, what was the molar mass of your anhydrous salt. So simply divide your grams by the molar mass, which you calculated from the periodic table, and you will have your moles. Okay, when you get to step number 4, it's fairly explicit. To determine X, the number of water molecules attached to your hydrate, you're simply going to divide your number of moles of water from line 2 by the moles of your anhydrous compound in line 3. You probably won't get a whole number, but round off to the nearest whole number. If for some bizarre reason you get less than 0.5, do not round off to 0, round up to 1. Let me repeat that. You have to have some number there. You can't have the number 0. So round off if you have a number less than 0.5, there was some experimental error, and round up to the number 1. Okay, now you will know what is the formula of your hydrate, because you were given the anhydrous version when you picked up bottles 1 through 5. You will draw a dot, and then you will put in 1, 2, 3, 4, whatever it is that you've determined in the previous calculation. And then in English, I want you to write the name of your hydrate on that line. For example, in English, I would write out, if I had had copper sulfate pentahydrate. So 5 is a chemical formula with the dot, and 6 are English names. Please notice that you won't be able to calculate step 7 and 8 just yet, and we will show you how to do the empirical formula after we've worked on that concept. I think that's it. At this point in time of the school year, though, Ms. Hackworth and I have realized that sometimes kids need chemistry tutors. So in this podcast and on the PowerPoint are some names of high school teachers that are experienced in teaching chemistry. And one of them is our own Mr. Lovelady here at Redwood High School. 2 others are former teachers that used to teach in the district. Or please contact me if you need some other suggestions on how you can get help to improve your grade. Until next time.